All right, a determinant is an alternating set of subtractions and additions using diagonals. So I'm going to show you how to do it by hand for the 2x2. Then I'll show you how to do it by hand for the 3x3. Fortunately, there is a determinant button on your calculator for matrices, so I will eventually show you that. I'm just going to say the 2x2, it's not even worth it. You just do it by hand. The determinant of A, B, C, D is AD minus BC. It's the number. So multiply the diagonals minus the anti-diagonals. So in this case, it's just going to be 4 times 3 minus 7 times 2, which is -2. So the determinant gives you a number associated with the matrix. And when we do Cramer's rule, we will see that you can use those numbers to actually solve equations. Ooh. Okay, so here's how this works for a 3x3. I take the first number times the determinant of the row and column that don't include. So I mentally cross off the first number's row and column and use the other 4 numbers. So 2 times, and I'm going to put -2, 0, -1, 5. That notation is for finding determinants. So what I'm going to do is I'm going to be finding the determinant of that in a minute. But then it's alternating. So it's always minus opposite sign. And then the next number.
That's a 1.
Times the determinant. If you cross off the 1 row and column, what numbers do you have? You have, so mentally cross off that middle column. You'll have 3, 0, 4, 5. And then back to 3, it's back to plus.
If the middle number is a negative number, you're subtracting a negative number. The middle number on the top row.
Okay, and if you cross off 3's row and column, you have 3, -2, 4, -1. Now I'll do determinants. So, which we just learned how to do, diagonals minus anti-diagonals. So -2 times 5, I'm just going to do that in my head, -10 minus, be careful, 0 times -1 is 0. So 3 times 5 is 15, 4 times 0 is 0. 3 times -1 minus -8. Okay, be careful with that. -3 plus 8 is 5. Grand total for this is -20. If you check on your calculator, the determinant button is in the matrix menu. You do determinant of that matrix. Okay, Cramer's rule. What happens is the bottoms, Cramer's rule is a ratio of determinants. And the bottom is always, always the numbers from the left side.
Sorry.
Okay, so when I build this, I'm going to say x equals, and then something over, the left side again is 2, 3, 5, 2. So okay, on the numerator, I'm going to replace a column. So for x, I replace the x number column by 310. So I'm going to keep 5, 2, but I'm going to replace the 2, 3 by 310. And I'm going to do that determinant. So 6 minus 50 over 4 minus 15. X is 4. Okay. For y, I replace the y column. Again, the bottom is always the numbers on the left. So this time, I leave the 2, 3 alone and turn this into 310. Okay, so make sure that you return 2, 3. Don't just switch the two columns, because the left side doesn't stay 5, doesn't turn into 5, 2. It's just like the bottom, except I erase the other column. So what have I got then? 2 times 10 minus 3 times 3 over, we still know this is a negative 11.
It's the same as the previous one.
So okay, the ratios needed to find x. Okay, so the bottom numbers are 3, 5, 1 going across. Oh no, we're missing y. What do we do? The obvious thing. And then okay, and again, if it's x, I'm replacing I'm replacing the x numbers with the numbers from the right. So we have 9, 10, 12, and then pop the other numbers up from the denominator. And then we would do that whole laborious process. If we were going to do it by hand, we would do it all. But I didn't say actually solve. I just said set it up.